Hi, in this video I'm going to do some examples with mean, median, quartiles, and box plots. My first example looks at salaries at a company XYZ. Now let's do the mean first. To find the mean, we're going to add up all the different incomes of the different employees at the company and then divide by the total number of employees. So in the table you see incomes and then a frequency representing how many people earn that income. And since all the incomes are in thousands, I think I'm just going to work with the number in thousands and begin by just writing out each income, let's say 15,000, and then multiply that by the frequency, and that way I don't have to write out 15 5 times. And then I have an income of 20,000, and I've got 10 of those, and there's an income of 25,000, and there are 10 people that earn that income. 30,000 with a frequency of 15, 35,000, and that has a frequency of 20, 40,000 with a frequency of 10. Now I'm going to divide by the total number of the frequencies, which is, you could say here, the total number of employees. Adding up all of the frequencies, I get 5 plus 2 10s plus a 15 plus a 20 plus a 10 and a 7 gives me 77. So there's 77 employees here. So that's the number on the bottom. That's the total number of the frequencies. Now adding up all these values, 15 times 5, that's 75. 20 times 10, that's 200. 25 times 10, that's 250. 30 times 15, that's 450. 35 times 20, that's 700. 2,400 on top, 77 on the bottom. Let's say roughly 31.2, since I'm going to put this in thousands. So when I say 31.168 thousand, I'm going to move the decimal 3 places, so that's 31,168 as the average mean income. Okay, now that we've found the mean or average income at this company, let's go back now and find the median income. Alright, now if I'm going to change the question to finding the median income, once again for the median income I'm going to use the total number of items in the data set, which is the total here of the frequencies. But specifically for finding the median now, I have to have the data in order, and it is in order from smallest at the top of the table to the largest at the bottom of the table. And when I do the median, one of the convenient tools that I have is this locator. The locator's always for the median 0.5 times the number of values. N is the number of values. In this case it's 77. So I'm multiplying 0.5 times 77. 0.5 times 77 is 38.5, and if we get a decimal we're going to round up to the next value. Even if this was, say, in another example, well, of course with medians you're either going to get a 0.5 or no decimal, but you'll see later that when I'm using locators, any decimal I round up. So I'm rounding up to the 39th value. That's the location. The locator tells me where the location in the data where the median occurs. So it's going to be the 39th value. So the 39th value, I'll start from the first 5 values here in the data. If we listed it out, we would have the data value 15,000 occurring 5 times. We'd have 10 more values of 20,000, so I could say that's 15 values. When I add 5 plus 10, another 10 more values means that if I listed them all out, I'd be at 25. Now 25 plus 15, that puts me at 40 values. So the 40th value is a 30,000, and the value right before that is 30,000. So now I found my answer. The median is the 39th value, which is 30,000. We could say that we have an odd number of values here with 77 values, and since that's odd, you could say that there'll be 38 values and then the median, and then there'll be 38 values. 38 and 38 makes 76, so you could see the 77th value that I'm counting total is my median value, which I put right in the middle. So the median is a value right in the middle of the data. In this case, I would have exactly 38 values less, exactly 38 values larger. All right, so that answers that particular question. Let's move on to another example. All right, I'm going to do another example with mean and median, but I've included one more person, one more employee in this income data set. See at the bottom of the table I have an income of 5 million and I have one person with this income of 5 million. So that's the only change that I've made, and I just want to demonstrate the significance of that and the difference it'll highlight for us clearly why we would compare both mean and median for a given data set. So we'll go with mean first. And as we're doing the mean, we'll do everything exactly as we did before. I'm just going to go through and write these out again. You can see here that I'm writing all of these incomes in thousands, and so when I get to 5 million, that's 5,000,000. So that 5 million income is showing up as a 5,000 here in my summation, and the frequency of that particular income is just 1. And I had 77 before as the total frequency, so now I have 78. And adding up all those values on top, so now we have 7,400 divided by 78. And again, if I want to put the answer in thousands, I'll round off to 3 places after the decimal. So we'll say 94.872 because it's a 1/7, so I'll round off 872. So the mean income is 94,872. So that answer of an income of 94,000 is more than all of these employees in this company except for one. So it no longer really is representative of a sort of center. It's still correct as the average, as the mean. It is correct, but it doesn't fully represent the data in the full, there's another way of describing and representing and understanding of what's called a measure of central tendency in the data, which is a sort of a center in a sense, which is literally the center in a different sense, which is the median. And the median is the value right in the middle. And so this kind of highlights why it might be also useful to look at the median income. It's really more representative, I think, of the set of data in this particular example when you have this outlier of 5 million. The outlier of 5 million brings the average way up, in fact higher than all the other data values. So it's the median that we might look to in a situation where there's an outlier. In fact, looking at this particular mean average income at roughly $95,000, that is almost double the highest income in the group besides the 5 million. Like an income of 50,000 is the largest income except for that one outlier, and 95,000 is almost double that. So it really shows how this mean is really pulled away from the rest of the data by that one outlier. And you could say that 95,000 doesn't really represent the average for all of these other employees. 95,000 isn't even close. It's almost double the highest income of that set of the majority of the employees. Okay, so that example there is meant to really make clear why the median is a necessary part of the description of the data, an important useful tool for analyzing and describing the data, looking at the median value. So let's calculate the median for this same data set. So now we're going to find the median, and we'll do this as before. We have 78 values, so the number of values n is 78. We'll multiply 0.5 times 78 to find the locator. Now 0.5 times 78 comes out to be 39. And when you get a whole number in this calculation using the locator in this way, when I get a whole number such as this, 39, no decimal at all, what I'll do in that case is find an average of the value at that position and the next position. So this implies finding an average of the 39th and 40th. The 39th and 40th values. Get an average of the 39th and 40th value. So let's go through the table again. We've got 5 values. The first 5 values are all 15,000, and then we've got 10 values here that are 20,000, and that makes 15. Add on 10, you got 25 values. Add 15 on top of that, and that's where you hit 40. So it just happened that the 40th value was the last of the 30,000. And I'm getting an average of the 39th and 40th values, which in this case they're both 30,000. Now it could happen that the 40th value might have been the first of these 35,000, and then I would take an average of two different numbers. But in this case, the 39th and the 40th, they're both the same thing. They're both 30,000. So that's the answer, the median. And you can see what the median is really good representative of the data in this particular example, because this is a data value right in the middle of all the data, and it didn't change at all by adding that one more person that makes $5 million to the company. The median is still 30,000, so it's less sensitive to outliers. Having the median is less sensitive to an outlier. It didn't change at all, in fact, in this example. You could say that looking at the vast majority of the employees, 30,000 really kind of represents a center value where you've got half the values less than 30,000 and half of them larger, and that's the case actually whether you included the $5 million income or not. Alright, well then let's move on to the next example. We'll look at quartiles and eventually the 5-number summary and the box plot. So this is the same data with incomes at a company that range from 15,000 up to 5 million. And this question asks for the first and third quartiles and to write the 5-number summary. It's the 5-number summary that I'll need to make the box plots. Alright, first the first and third quartiles. We do the first and third quartiles the same as the median. In fact, the median was the second quartile. It represents a data value where you've got 50% of the data less than the median. A first quartile is a value which you have 25% of the data less, or at least approximately. And the third quartile is a value which you have 3/4 of the data, 75%, or at least approximately 75%. The quartiles don't necessarily always come out that you have exactly 25% of the data less or 75% of the data less, although the median does work that way so that it's exactly 50% less. Alright, so let's do the first quartile. First quartile is done by using the locator in exactly the same way as the median. We'll multiply 0.25 for the first quartile times the number of values. N was 78. There's 78 values. So 0.25 times 78, this comes out to be 19.5. And I made a comment earlier that when I get decimal values, no matter what that decimal value is, I'm going to round up. Even if this had been 19.1 or 2 or whatever it might come out to be, I'm going to always round up in the locators to the next value. So this is telling me I want the 20th value because it's a decimal. If it's a decimal, you always round up in all of the locators. If you get a whole number in all of the locators, what you'll do is take an average of the value at that particular position and the next position. So I need the 20th value. So there's 5 values here plus 10 more, that's 15. Adding on 10 more, that's 25. So I could see that my 20th value belongs in this set of 10 values, which are all 25,000s. So the answer, the first quartile, is 25,000. Let's calculate the third quartile. Once again with a locator, this time because it's the third quartile, we're going to look for a point at 75% of the data, which is 0.75 times the number of values, 0.75 times 78 values. 0.75 times 78 gives me 58.5. And again, I got a decimal, so that means I'm going to round up to the 59th value. Doesn't matter what decimal you get, you round up all the time with the locators. And had I gotten a whole number, I would have taken an average of the value at that whole number position and the next position. So, for example, if I gotten 58 here, I would have taken the 58th and 59th values, taken an average of those two, and called that the third quartile. Here, being a decimal, round up, 59th value. All right, now I got to go through and figure out which of these is the 59th value. 25 values here plus 15, that gives me 40 values. Another 20, that gives me 60 values. Okay, so the 59th value would be in this set of 35,000, these 20 values that are all 35,000. So the answer for the third quartile is 35,000. All right, with this information, now I am in a position to write the 5-number summary. The 5-number summary is the minimum, the first quartile, the median, which happens to be the same as the second quartile, then the third quartile, and then the max. So you have 1, 2, 3, 4, 5 values. Well, the minimum value here is 15,000. I'm not going to put the comma because I'm using commas to separate those numbers in the summary. The first quartile, that's 25,000. The median, well, we've done that median. Back here, when we calculated the median, we found that to be 30,000. So for this same data, I had a median of 30,000. The third quartile, I found that to be 35,000. And finally, the max, that's the 5 million. And so that's what we call the 5-number summary. It represents a minimum, first quartile, median or second quartile, third quartile, and max. Basically breaks up the data into 4 equal quarters. Lowest value, a first quarter value, a second quarter value, a third quarter value, and a maximum. So that completes that example. Alright, so for my last example here, I'll take an example out of our book. It says, this is from the Math and Society book, chapter on describing data, and it's the example 25 in the book. It says, suppose we've measured 9 females and their heights in inches, sorted from smallest to largest, and there is our given data for these heights. We'll create a box plot with this data. So the box plot, what we do for the box plot is to use the 5-number summary. So I'll go through and find the first, second, and third quartiles, minimum and maximum, write the 5-number summary, and use that for the box plot. So the minimum, 59, the maximum, 72. Of course, you got to make sure the data is in order. And now, specifically, to get the quartiles right, you've got to put it in order from the smallest to the largest, so that your first quartile really is and third quartiles are correct only if it's in order from smallest to largest. So the locator is 0.25 times the number of values. 0.25 times 9 is 2.25, and so again a decimal, so I'm going to round up to 3 and take the third value. The third value is here at 62. Now, just a comment about that, if you take 62 as your first quartile, that means that there are 2 values less, and 2 values out of 9 total is 22% of the values. So here's that comment that I made, where I can make this comment about it's not necessarily always exactly a point where you have exactly 25% of the data less than the first quartile, but it's roughly true. In this case, it's actually 22% of the data, 2 values out of 9 less than the first quartile. So the first quartile is 62. Let's get the median. The locator is 0.5 times the number of values. That comes out to be 4.5. Again, that's a decimal, so I'll take the fifth value. And the fifth value is 1, 2, 3, 4, 5, 66. So with the fifth value, I have 4 values less and 4 values greater, and so with that value, I really am right in the middle with 50% less and 50% more. So that's the median, or second quartile. Third quartile, locator 0.75 times the number of values. This is 6.75. Being a decimal, I'm going to round up to the seventh value. The seventh value, 1, 2, 3, 4, 5, 6, 7. That's 69. Now with the seventh value, I have 6 values less, and 6 values out of 9 is 67% of the data. So again, not exactly 75%. 6 values out of 9 is 67%, but roughly a 3/4 point. If I went to the 8th value, then I would have 7 values less, and 7 values out of 9, that's 77%, so that doesn't work either. So we use this formula consistently, where we take 0.75 times the number of values, and if it's a decimal, you round up. If it isn't, you take an average. So in this case, third quartile, 69, and the minimum and maximum are clear. So in order to create the box plot, I have a 5-number summary, which is 59 for the minimum, first quartile 62, second quartile 66, third quartile 69, and maximum 72. And now I can create the box plot with those values. Okay, so this is the 5-number summary that I'm going to use. Using that 5-number summary that we just calculated, you see the minimum is the 59. So when we create a box plot, what we do is we'll have the minimum we'll have a box with these 2 whiskers here. Minimum, this is the first quartile, this is the median, third quartile, and max. You make a box plot by creating a rectangle that has as its left end the first quartile and right end third quartile. The median is a line that divides that box, and then these whiskers or arms for this box represent values that reach to the minimum and maximum. A nice technique to use here when you create the box plot is to actually draw out a number line first, and then you can draw the box and its whiskers with appropriate scale, with the scaling adjusted appropriately. It can happen sometimes that the minimum and the first quartile might be the same, and so the whisker doesn't show up on the left, or the third quartile and the max, they could be the same, and so there is no whisker on the right hand side. It's possible that the second quartile could be the same as the first or third, and so this line here doesn't always show up in every box plot. It may be that it's the same as the first quartile or the third quartile and doesn't show up for that reason. Alright, well, that is the end of that example, and that's the end of my video. I hope it was helpful.